Hi guys, Jake here bringing you the first of hopefully many videos going through some of my development in Unity. So I'm going to show off what I've done, how I've done it, and hopefully I'll explain some of the reasoning behind it, but oftentimes that reasoning is going to be something like it seemed like a good idea at the time. So just before we begin, I'm a web developer, so new to C#. I've dabbled in Unity a little bit, but fairly new to Unity as well. Everything you see here is subject to change. It may not be the best way of doing it, but I'm showing it off because it's working for me at the moment. If it's ever not working for me, hopefully I'll describe that in another video and we can learn together. So let's dive in and see what's going on. So I've got a scene here. It's basically got a plane and it's got a grid on here. Ignore these radial nodes for now, that will be covered in a different video. The grid that I'm using is inspired off Jason Weimann's YouTube video, so I'll put a link to that in the description. It's working pretty well for me. I've modified it a little bit, but yeah. So I'll run the scene and we can see what's going on. So I've got some shapes. I can flick through different shapes, but they are basically the Tetris blocks. I can rotate those shapes as well. So we can see over on the side here, my shapes have a rotation integer that I can set. Now this rotation can either be 0, it can be 1, or it can be 3. I would like to make it so that the editor only gives me those 3 options because I can't rotate anymore. It makes no sense to have something that can rotate 2 times and not the full amount. So that'll be something hopefully I discover down the path and can share. So I can place these blocks and rotate them around. If it detects any sort of space is occupied, then we can see here that the block or the shape goes red. And the actual parts that are intersecting, I've turned those game objects off as well, just for clarity. We can also check out of bounds, so going out here, we can see that those blocks disappear and we can't place any shapes off to the edge. Yeah, which is quite cool. So I'll jump into the code. There will be a reason as to why I'm doing all this, but we'll see that unfold as I develop the game more. But yeah, let's jump into the code and how these things are happening, essentially. So I do have a level on here, which has the grid system. So it's got dimensions and tile size, and it's also got a reference to the camera as well, so that I can do some raycasting. And most of this, I think, is what you'll see from Jason's video on YouTube. I also have a shop builder here, which I'll talk about. It has access to the grid, and it's got a selected shop. This is just, at the moment, it's a placeholder. When I place a shape down, these are 4 blocks that get instantiated. You can see them over here, they're just clones. So that's inefficient, but at the moment it's just placeholder dummy stuff. So yeah, that's what that is. So yeah, let's jump into the actual code now. So let's start by having a look at the grid. So if you go and look at Jason's video, you'll see how this sort of works. But the grid system, one key point, this part here. So I've got some occupied spaces, and that's just a Boolean 2D array which tracks whether or not the space is occupied. So I tossed and turned quite a lot here as to whether or not to store a 2D array, or whether I should just have the colliders, box colliders on my shape once it's been placed and detect collisions like that. But doing a bit of research, it sounds like I would actually use sphere colliders because I think they're the most performant, but it sounds like collision detection is yeah, pretty gnarly in terms of performance. So I think having this variable is better. So yeah, that's something I may regret down the line, but at the moment that's what I've got. So that's one sort of piece here. In terms of how else it works, so I've got this callback or this subscribing function here. This is pretty, I don't know whether this is a great way of doing this, so if anyone's got feedback, I'd love to hear it. But essentially, in my update function, so we cast a ray from the main camera, so this is all stuff that you'll see in Jason's video, but basically we're detecting whether or not we're hitting the floor, and we get the nearest point. We check whether or not the point's out of bounds, and if it is, we're going to set the new point to be an invalid point. This is just a constant that I've got up here, set to a completely random, well, it's not random obviously, but it's set to a point that's miles in the distance that will never actually be a point on my grid, and that's specifically there so that I can use it to detect whether or not we've got a valid point, basically, so I can do a vector equation check, or equality check rather. And here we've got a function that checks whether or not the point's changed. If it has, then we assign the new point, and we call this subscribers. So basically what happens is any script that I've got that might be interested in knowing when the point changes, and this is specific for the shape movement, it subscribes to listen to this, and then when the point changes, we essentially broadcast. So it's just like a pub sub event type system. I don't know whether that's the best way of doing it. It may very well be that I should be using Unity's event system or something like that. But when I started looking into the event system, I got a little confused as to whether or not it was a good idea. And this worked for me at the time. The one risk that I do sort of have, or main concern that I've got with this, is at the moment I'm subscribing, but I'm never unsubscribing. So if the things that subscribe ever get destroyed, or I deactivate them or anything like that, I'll end up having a reference here, I think, that'll throw errors. So that's a potential problem, but at the moment I don't think that will be the case. Down the line I may need to do a safety check there, or just handle this in a completely different way, so we'll see how that goes. But yeah, essentially this grid, it handles worrying about whether or not the spaces are occupied. So we can see here we've got some is occupied. These methods are basically the same, they're just one can take a vector 3 and the other can take some hints, which is just useful down the line. I can toggle on or off whether or not the space is occupied. I've got a little helper method here that checks whether or not the current point is out of bounds or whether it's on the grid, and I've just got some gizmos to draw all the lines and stuff on there. This nearest point, so you can have a look through Jason's video if you want to know how most of this is working, but yeah, that's kind of what's happening to the grid. One thing that I spent a bit of time on, which was painful, I had somehow missed this distance parameter here, and so it looked like this, and for probably a good 2 hours or so, I was trying to investigate why the heck why my raycasting wasn't working properly. I didn't actually know it was the raycasting that was the problem, but my shape wasn't appearing in the spot it should appear, and it was moving around, yeah, strangely and that sort of stuff. And it took me ages to spot this, so just be careful that you've always got your distance in there. I think this ends up being either a float or an integer, and it just quietly plugs into this parameter section here, which is yeah, pretty brutal. So next script we'll look at is the shape. Let me go into the editor again. So I've got a bunch of prefabs here, and these are just my shapes. They've got the shape, they've got the rotation, and the key thing that they're kind of here for is their transforms, so position and rotation. There is an argument that these There's an argument that this doesn't have to be a mono behavior, I guess, because it doesn't have a heck of a lot going on in terms of being a game object. Really, I just care about the position and its rotation. So arguably I could make this just a data object, a struct or something like that. I don't know what's better here, but having the prefabs there are nice. So for now, I'll keep it like this. It shouldn't be too hard to change down the line. So if I jump in and have a look at the shape script, so the shape script, as you can see, it's got those rotations. So this should be, as I said, 0, 1, or 3. We keep a record of what the current rotation is at. We've also got the tiles, so each shape is made up of 4 tiles. And then I've got this delegate void function here, and I use that down here, which basically gives a public method to go in and loop through each of these tiles and run a function on there. So I found this has actually been quite useful. Again, not sure whether this is good practice or anything like that. It might be risky, but I found this to be quite useful. So I'm doing it at the moment. When we look at the shop builder, you'll see, why I say that this is quite useful. So when we start, we go through and we grab all the children that are in the block, and we have this little struct up here that just holds the transform and the renderer. Again, not sure if this is great, but it gives me a reference to both these things, so I don't have to go doing get component constantly or store. So it just gives us a reference to that. So I set those up, so we've got an array here of those 4 things. Down the line I may have shapes that are more than 4, which is why everything's kind of flexible in that sense. We've got a public method here that is rotate, so we increment the rotation counter. We then check whether or not we are over the maximum rotations that we've got here, and if we are, then we're going to rotate it and we're going to go backwards. So if we've rotated over 3 times already, we basically reverse right back, and then we add this 90 just to counteract the fact that we've gone over the rotation. But if we haven't gone, and of course we reset the current rotation to 0. If we haven't gone over, then we just rotate at 90 degrees. So pretty simple there. And this is just the for each. These things are just helpers. I wouldn't worry about this at the moment. This is semi-interesting. So before I was using the game object as a rotation. If I was to go back and make this just a purely like a data structure as opposed to a mono behavior, or with a game object attached to it, there's this little algorithm here that works out basically how we can change it just using the coordinates. So if there's I'm using X and Z, you can just as easily, if you're using a 2D grid, refer to it as X and Y. But this little calculation, if I pull up here, I was scribbling to figure this out, but basically this is how I worked it out. So when our X rotates, it jumps up here, so it becomes Y essentially. So X becomes Y. This isn't written very well, but X becomes Y, and then we times it by -1, and Y is just X. And this little formula here works if you just want to rotate your shape. The middle one obviously stays static every time. It's 0 and 0 no matter what, but these outside blocks will shift accordingly if you apply this little formula to them. So kind of cool. If I ever go out of having these as a mono behavior with rotation, then I'll end up having that there, which is why I just commented it out, so I haven't gotten rid of it completely. Alright, so now we'll have a look at the shop builder. So this is probably the kind of most gnarly script that's going on. And this one here So it's essentially the kind of shape manager, I guess. At the start, we grab all the shapes that this thing has, and I can show you down here. So our shop builder has, I've got all of those prefabs preloaded in, and they're just disabled to begin with. So it's got all of those, and then we grab a randomized shape. So this function here basically goes through our index. The first thing it does is if we had a shape previously, it will turn that shape off. We then determine a new current shape index. Sorry, my mouse lagged up a bit there. So we determine a new current shape index just using the range, so from 0 to shapes.length. And then we activate that and we set the position of it, so the position of that particular shape to our grid's current point. So that's what the randomized shape method does. So we do that on start up here, and then this is that method. So we go into grid and we subscribe to point changes. So every time the point changes when we're raycasting, it calls this function, and all this function does is assign the current point on the grid to the to the transform of our shape, and it calls this validate function. So if we come down and we look at the validate function here, so the validate function kind of is doing what it says it's doing. It's checking whether or not our shape is in a valid spot on the board. So we've got this variable up here, our valid position. So we set that to true. We then use, this is that utility method that I had on the shapes in the shape script. So this thing here. So we're just passing a callback in, and that loops through and runs that callback for each of the tiles there. So it checks whether or not the space is valid for that particular tile, and if it's not valid, then we set our we set our Boolean valid position to false. We turn the game object off, so this may be multiple game objects, it may only be one, depending on how much of our shape is sitting into an invalid spot or hanging off the map. And any of the ones that aren't in an invalid spot, we make sure that they are turned on and active. And then this is just some placeholder stuff, but it changes the color from green or red depending on whether or not it's valid. So that's what the validate method does. We've spoken about the randomized shape. This build is just a it's just kind of placeholder, but when we click the mouse button, so if I show you the update method, this is just handling some inputs. So if we press the full stop button, we get a new shape, and we validate that new shape to see whether or not it's already in a valid spot or not. We also get the mouse button down here. This builds, so on left click we build the shape, and on right click we rotate the shape, so just calling the rotate method in shapes. So all this build method is doing at the moment is looping through each one and building a single block. So it just instantiates that, which I know is very unperformant, but it's just dummy placeholder stuff at the moment to get things working. So that's it. That's how everything's working at the moment. I'm pretty happy with it. It's gone through a couple of iterations, but I'm pretty happy with it now. I've been playing with I don't remember, it's Aaron someone, I'm not sure what his last name is, but his pathfinding. That'll be the next thing that I'm looking into doing, and having some pathfinding navigate around these shapes on the board. So that'll be hopefully the next video. Cool, thanks for listening. Hopefully I didn't ramble too much. This is the first video I've made like this, so hopefully it's alright, and hopefully I carry on and do some more, and see you guys later. Cheers.